Carbon-carbon double bonds cannot rotate like carbon-carbon single bonds. So if you have atoms or groups attached to carbon-carbon double bond, they may form two different structures which are named as cis and trans isomer. How do they look like? So for alkene, when you have the double bond, we learned that it is rigid and does not rotate, so it holds the attached groups in fixed positions. For cis and trans, they are also known as geometrical isomers. Depending on what side of the carbon they are present and depending on their orientation, we have to use cis or trans to reflect the arrangement of the groups around the double bond. So for cis and trans, we have different physical and chemical properties. They cannot occur when two groups are the same on one side of carbon. So if you consider these compounds where carbon is attached to 2-chlorine in one side, it cannot generate cis-trans isomers. It has to be different. For example, in this compound, each carbon is having 1 chlorine and 1 hydrogen. So two groups are different from each other. So they can generate cis and trans isomer. When you have the 2 chlorines or the two same groups are on the same side of the double bond, they are known as cis isomer. And when the two groups, the same groups, are towards opposite direction, then they are named as trans isomer. So in this case, the compound has 2 carbons, so it is ethene, a double bond, and 2 chlorine substitution at number 1 and 2 carbon. When they are organized around the same side of carbon, it is cis-1,2-dichloroethene. But when they are directed towards opposite direction, we name them as trans-1,2-dichloroethene. Similarly, this compound where you have 2 bromine, the first one where the 2 bromines are towards the same side, it is named as cis-1,2-dibromoethane, and when they are directed towards opposite side, it is named as trans-1,2-dibromoethane. Now, for naming of these compounds, we have the first one where 2 methyl groups are towards the same side, so it is a cis. 2 methyl groups towards the opposite side, it is a trans. And the last one, also 2 methyl groups are towards opposite direction, it is also a trans. Now, this type of alkene chemistry is not only limited to our everyday life, it is also present in environment. Pheromone is one type of hormone which includes this type of hydrocarbon present in them, and it is used to warn an insect of danger. It is also can be used to mark a trail to attract the opposite sex. This is also an example of bombyco, which is a sex attractant for silkworm moth. If you look at the structure, it has 2 double bonds present and it has a long chain of hydrocarbon. Between the 2 double bonds, one is cis and one is trans.